Okay, welcome back, calculus students. This is going to be section 3.3. 3.2 dealt with, or 3.1 dealt with finding critical numbers, and then 3.2 dealt with the mean value theorem and intermediate value theorem, which we happened to cover before the spring break holiday. So now we're going to skip it and go straight to 3.3. 3.3 deals with functions that are increasing, or where functions are increasing or where functions are decreasing. If you think about it, there are three things that have to happen for a function to change, either from increasing to decreasing or decreasing to increasing. Now, for the purposes of this, I'm just going to go where we're changing from increasing to decreasing. One way to change from increasing to decreasing is to come and have a place where you have a function that is not differentiable. In other words, the derivative does not exist there. A second way that you can change from increasing to decreasing or decreasing to increasing is to have a place where the slope is zero, like an upside down parabola. This changes from increasing to decreasing, and it changes only where the slope is zero. So those things we kind of hit on a little bit earlier. The other way we can check to see if a function is changing from increasing to decreasing is if we have a region where all of a sudden the function is not differentiable, or the function is just not continuous there. So these are three examples. So really these two fall under the same category. The only difference is this function is continuous, this function is not. But at the point where we change from increasing to decreasing, the function is not differentiable. Here the function is differentiable, and in order to be differentiable, it has to be continuous. The function will not be differentiable if it's not continuous at the point. So that's what we're looking at first off. Now, how do we determine where a function is changing from increasing to decreasing or decreasing to increasing? And then over what intervals? Well, I'm going to take a function that we're familiar with, sine of x. And let's just look at sine of x going from, I gotta find my eraser, 0 to infinity. Not 0 to infinity, okay, that would be infinite. From 0 to the famous wrapper 2 pi. So here we are, 0 goes up to 1, crosses at pi, and here we are at 2 pi. Now, we know this to be pi over 2, and we know this to be 3 pi over 2. Now, if you think about what's significant about these two places right here, at pi over 2, we're going from increasing to decreasing. At 3 pi over 2, we go from decreasing to increasing. Also note that at both of these points, you have a slope of 0. Well, now let's look at this as if we don't know what the graph is going to look like. So let's take f of x equals to the sine of x. All right? Well, f prime of x is, again, cosine of x. Now, what do we know about cosine of x? Cosine of x does the same smooth curve, just shifted, that sine of x does. So it's going to be differentiable everywhere. We do not need to check to see where cosine of x is not differentiable. So let's look now at where the cosine of x is equal to 0. Well, you could do the cosine inverse of 0, and you would come up with pi over 2 and 3 pi over 2. So these are the two places where cosine of x is equal to 0. So these are going to be our two potential places. It may, bless me, it may or it may not change there. Now, let's look and see how we're going to analyze this. Again, we said that we were just going to be talking about, and I'll use a closed interval. It doesn't necessarily have to be closed here. But let's say that we're going from 0 to 2 pi. Well, we know in that interval from 0 to 2 pi at pi over 2 and at 3 pi over 2 we have a slope of 0. So what I'm going to do is I'm going to put those two numbers on a number line. Okay, so by putting these on a number line, I have three different intervals. My first interval is from 0 to pi over 2. My second interval is from pi over 2 to 3 pi over 2. And my third interval is 3 pi over 2 to 2 pi. Now, thinking a little bit further along the lines of this, let's consider what the cosine of pi over 4 is. See, pi over 4 would be in this interval from 0 to pi over 2. All right, the cosine of pi over 4 is the square root of 2 over 2. But the main thing is, it's positive. So because cosine is positive from here to here, and it's referring to the first derivative, this is telling me, hey, I'm increasing here. And if it's increasing for one value in that interval, it's going to be increasing for every value in that interval. Because remember, these are the only two places where we can change from increasing to decreasing or decreasing to increasing. We showed that in the earlier graphs. All right, now let's go here and let's look at, I don't know, between pi over 2 and 3 pi over 2, let's just choose 3 pi over 4. Now, I'm not going to get the exact answer here for 3 pi over 4, but what I want you to think of is this. Think about what quadrant 3 pi over 4 would be in. 3 pi over 4 would be in the second quadrant. And what do we know about cosine in the second quadrant? That's right, class. It's negative. So the graph here is going to be negative. So it's going to be, because it's the derivative, that means we're going to be decreasing everywhere in that interval. Now, the final interval, and again, let's think about it the same way as far as quadrants are concerned. We're going from cosine, or 3 pi over 2 to 2 pi. So if you think about the quadrants, this would represent the fourth quadrant. And what do we know about cosine in the fourth quadrant? Well, cosine in the fourth quadrant is positive, so we are increasing everywhere in this interval. And that does match what we had earlier on our graph. So I would say that I'm increasing from 0 to pi over 2, union that with 3 pi over 2 to 2 pi. And then I would say I was decreasing from pi over 2 to 3 pi over 2. Okay, so some very good examples to work from this. Again, we said we were on section 3.3. Again, critical numbers, you'll see this referred to in some of the directions. Critical numbers just refer to where your slope is 0, where your slope is undefined. But critical numbers are numbers that are actually defined in the domain. So a good set of problems to do from this section would be 17 to 37 and... Well, that would be good for right now. 17 to 37. Again, do the odd problems so you can check your problems in the back of the book. Please email me any questions if you have them. Hope that this goes well for you. Next time we will discuss what we're going to do as far as taking our third test is concerned. Have a good day. Bye.